Up to this point, when we've solved equations, we have basically performed one operation. We have either added or subtracted on both sides of the equation, or maybe we've multiplied or divided on both sides of the equation. But we get the isolation of the letter very quickly from one of those processes. And isolating the letter is the matter of solving the equation. Okay, now we're going to talk about some equations in which we have more than one operation to perform. Take a look at this equation. We have 5x plus 8 is equal to 6, and in order to isolate the letter, we need to get rid of this plus 8 and we need to get rid of the 5 somehow. Well, we're going to use the same techniques that we used before, and I think a good way to think about this is to target the notion of isolating the term involving x first, and then isolate the x by dividing by this numerical coefficient. All right, here's what I mean. If we think about isolating the term involving x, it means that we're going to try to get rid of this plus 8. And to do that, we'll subtract 8 on both sides. Here's what we want to write. You write the left side of the equation and then show that we're subtracting 8. Write the right side of the equation and perform the same operation, subtract 8. So here the 8's go out and we're left with 5x, and on the right 6 minus 8 is negative 2. And now, to isolate the x, we'll divide on both sides by the 5. So we want to show that we're doing that. We want to show the division by 5 on both sides. These cancel as expected, so we find x to be negative 2 over 5. Now, we can write this as negative 2 over 5, or we can write it as negative 2/5. Either way is okay. Here's another one. Same idea now. We're just trying to isolate the x. And we first want to isolate the term involving x. So to do that, we'll get rid of the 7. And to get rid of the 7, we subtract 7 on both sides. So we write 7 minus x minus 7. You see, the 7 minus 7 will go out. Now, if we subtract x on the left, we need to subtract x on the right. Excuse me. If we subtract 7 on the left, we need to subtract 7 on the right, and away we go. 7 minus 7, 0. So we have negative x here. 3 minus 7, negative 4. Now, we have negative x is equal to negative 4. But do we want to know what negative x is equal to? No! We want to know what x is equal to. So we have to somehow get rid of that minus sign. And there are actually a couple of ways to do that. One way is to say, well, let's just divide on both sides by negative 1. And somebody else might say, well, why don't we just multiply on both sides by negative 1? That would do it. You see, either of those techniques is fine. If I think about multiplying by negative 1, you see it's multiplying by negative 1 on both sides. So negative times negative, positive x. And then negative times negative, positive 1 times 4, 4. So x is equal to 4. Now, once again, I want to make sure we understand that we have the opportunity to check to see if this is a valid solution. And we can do some of these mentally, or we can actually show the check using the techniques we've talked about before. If we just kind of look at it, though, if x is 4, if we're saying that x is 4, just kind of look up here at the beginning. If x is replaced with 4, then we can imagine that this would be 7 minus 4. You see, 7 minus 4, though, is 3. We would have 3 equals 3, truth, and therefore a valid solution. Here's another one. Now, on this one, I want to show you two techniques because there are certain situations where one of these techniques is going to represent the easiest way to work the problem, and the other technique will represent the easiest way in other kinds of problems. But one way is to do this, is to say, well, let's see, we have a term involving x, and we have a constant term over here. Let's get rid of the constant term first. All right, so let's do that. We'll add 1 on both sides to accomplish that. So x over 4 minus 1, now add 1. And on the right, add 1 to the 3. The 1's go out, and we have x over 4 equals 3 and 1, 4. Now we'd like to clear that 4. Notice that it's in a denominator. And since it's in a denominator, and we can interpret this as saying x divided by 3, the inverse operation for division is multiplication. So we could simply show the multiplication of 4 on both sides in order to accomplish the cancellation of this 4. And it would look like this. So we would show 4 times x over 4, and on the right, 4 times 4. So these 4's go out. We find that x then is 16. All right, that's one very good way, and I think this is probably the best way to solve this equation. Now, there are certain situations, though, involving fractions in equations where another technique will be preferred. Not on this one, but on some other ones. And I want to just show you the technique. The technique involves thinking through it this way. The technique involves saying, well, you know, I've got a fraction in this equation, and I really don't want to mess with fractions. I don't want to have to deal with them. I don't like to find common denominators and so forth. Not that we have to here, but we might in other problems. And so I'd like to get rid of the fraction early on in this process of solving. And it's pretty easy to do by using the same technique that we did down in this equation, except we did it late. But we can do it early. That is, we can say, well, I'd like to get rid of the fraction first. And to get rid of that fraction, I multiply through by this denominator. So I would show that 4 can be multiplied times this term, and then 4 times this term, and then 4 times this term. Now, understand, what I'm really doing here is I am thinking of multiplying 4 times the left side and 4 times the right side. You see, it's kind of like this. And 4 times 3 on the right, that's trivial, but this is important. It's 4 times each of these, and I'm distributing the 4 by doing this. You see, by writing this step. So this gives me the reason that I can write all of this down. So that's the idea. Now, notice also that in going through this process, I put the 4 factor that I'm introducing in here. I'm multiplying every term by 4, and I just pop that 4 factor in between the minus sign and the 1. I just put it right in between. You see, I'm just popping a factor in there. You see, and I'm doing it for the purpose of removing this fraction, but it's okay to just pop a factor into every term as long as you do it for every single term throughout the equation. You maintain the balance of the equation. All right, the 4's go out here, leaving x. And then this is minus 4 times 1 is minus 4. And on the right, 4 times 3, 12. And now, to clear the negative 4, we add 4 on both sides. And minus 4 plus 4 go out, and so we're left with x on the left, 12 and 4, 16 on the right, and we're getting the same result that we did before as expected. Here's another one, and when the term involving x, or whatever letter we're solving for, could appear on the left side of the equation, the right side of the equation. It could be the first term or the second term on the left side or the right side. It may appear just anywhere. Don't let that intimidate you at all. The idea is the same in solving. We'd like to isolate first the term involving the letter. And let's do that. We can isolate this term by clearing the 8. We clear the 8 by subtracting 8 on both sides. And let's do that. We would show then, we would bring down the left side and subtract 8. We would bring down the right side and subtract 8. 8 minus 8, 0, they go out. So we have negative 6x on the left. On the right, 14 minus 8 is 6. And now to clear the negative 6, we would divide on both sides by negative 6. So negative 6x divided by negative 6, and on the right, 6 divided by negative 6. These cancel as expected, so we find that x is equal to, let's see, positive divided by negative is negative, 6 divided by 6 is 1. So our solution then is x equals negative 1. Let's check it right quick. If we're saying that x is negative 1, then we replace x with negative 1. We would have negative 1 times negative 6. Oh, that's positive 6. So 8 plus 6, 14. 14 equals 14? Yes. So this is a valid solution. Here's an interesting problem. It's the first one of its kind, I think, that we have faced. And it's one where it looks like we have a little bit to do. We have a simplification opportunity on the left side of the equation. And this is how equations, this kind of equation, become more and more complicated. They become complicated because there is some simplifying to do on one side or maybe even on both sides of the equation before we actually go through the process of eliminating terms. Now here the simplification involves bringing these two like terms together. So 5x minus 3x would be 2x. And now it's an equation that we're very familiar with. To isolate the term involving x, we would clear the 2, and to do that we would subtract 2 on both sides. So we have the left side subtract 2, the right side subtract 2. 2's go out and we're left with 2x. On the right, 8 minus 2 is 6. Now we divide on both sides by 2 to find that x is equal to 3. Here's a problem involving a formula. It says, using the formula, boom, there's the formula. Now this is the formula, by the way, that correlates Fahrenheit temperature with Celsius temperature. And we're going to use this formula to find the Celsius temperature when the Fahrenheit temperature is 212 degrees. Now, in order to do that, now notice, now F stands for Fahrenheit temperature and C stands for Celsius temperature. When using a formula, you always follow the same sort of prescription in the first two steps. In the first step, you write the formula. In the second step, you replace letters with numbers. Now here we're only replacing one letter with a number, but we're told that the Fahrenheit temperature is 212. So we're going to replace the F then with 212. And then we're going to solve for C. Let's see what it looks like. I'm going to come over here because it kind of looks complicated a little bit. We're going to have several steps, and I'm going to run out of room over here to the right. So I'm going to come over here, and the first thing we do is write the formula. Now, we replace letters with numbers. The Fahrenheit temperature is given to be 212. Now, once again, we could take two tactics here. One tactic would be to isolate the term involving C, and we would do that by subtracting 32 on both sides. Another tactic would be to clear the fraction very early, like right now, and we could do that by multiplying throughout the equation by 5. That is, multiply that term by 5, this term by 5, and that term by 5. You see, so either way would be perfectly all right. I think I'll just isolate the term involving C, and to do that I'm going to subtract 32 on both sides. So it's 212 minus 32 equals the right side minus 32. And now on the left we have a little subtraction to do. And don't trivialize this. Don't think that this is something that you can do in your head. Don't even try it in your head. You want to write it down somewhere, perhaps out to the side, but I'm just going to work it right here and then erase it because I have a handy eraser. So 212 minus 32, you see, and here's the way I'm thinking about it. 2 minus 2 is 0. 1 minus 3, oh, won't go. This is 1 then. The one that I borrow makes that 11. 11 minus 3, 8. And so it is, and 1 minus 0, 1. So 180. So I get 180 on the left, and on the right, the 32's go out, leaving 9/5 C. Now I can clear the fraction all at one time. Remember from a previous section, I can clear a fraction by multiplying through by its reciprocal. So I can multiply on both sides by 5/9. So I would multiply on the left by 5/9 and on the right by 5/9. Now, this is a trivial cancellation. The 9's cancel, the 5's cancel, so I'm left with C as expected. And now I need to perform this operation. Well, the 9 and the 180 can cancel. 9 into 9 goes 1. 9 into 180, well, let's see, 9 into 18 goes 2. And then 9 into 0 goes 0. So 20. And then 5 times 20 is 100. So 100 degrees is the Celsius temperature corresponding with a Fahrenheit temperature of 212 degrees.